Okay, so before we begin, did either of you get a chance to read through the Haber process and the contact process from the text? I'll take that as a no.
Honestly, should I be honest or should I lie?
I mean,
Honestly, no.
yeah, but that is what I understood from
Haram
the.
as well said in the
Yeah,
chat.
yeah, I saw. Right, so do for wrong and Sobia, right, especially you. Uh,
What?
well, you have the IGCSE syllabus, right? So
Yeah,
whatever,
yeah, yeah,
yeah. So you need to keep track
yeah,
if
yeah.
there's anything missed or if there's anything that should have
Mm,
been covered. You do have an
mm.
understanding uh, that
That,
there are slight differences between the O level and the IGCSE syllabus, right?
okay, yeah,
The,
yeah, yeah.
the the stuff in the green box, the going
Mm,
further is not part of the
yeah,
syllabus. The
okay,
stuff that's given in yellow is part
yeah,
of the extended syllabus, but since you are doing the whole thing, so it's all the same for you,
yeah.
right?
Mm.
So just follow along the chapters.
Basically, keep
Be
track.
Yeah, keep track of whatever we're doing,
Yeah. Mm.
right? And in case I've missed something that is in the IGCSE syllabus and I
Read
haven't,
along.
yeah, so highlight that for me.
Okay,
Read it. If you understand it, you don't feel like you need much of an explanation for that, that's well and good. If you do need an explanation, highlight that for me,
okay,
right? And I will go back to
sure.
it. Okay, so
Yeah.
today we are starting with chapter 11. We are making good
Good progress.
progress. We are making good progress, right?
Yeah.
So the textbook has 14 chapters,
Oh,
and yeah,
okay.
and we are on chapter 11. We skipped chapter 4. So we've covered 10 minus 1, that's 9 chapters, and that is definitely right. 9 is definitely more than 7. So we are well beyond half the syllabus.
Yeah, I think chemistry will be done sooner than physics, right?
Probably yes,
Yeah.
right?
Okay.
And so that would give us more time for practice with past papers,
Yeah, that's good.
right?
Hmm.
So, and of course that is provided that you guys are following along, right?
Yeah.
So there's some stuff in this chapter that is sort of like, yeah, we know, what's special about that. This is just stuff, and this is just stuff that you could very well, just read. But the thing is, when I went for my training, my Cambridge training, and the sample candidate responses that we were given to check, uh, we normally have like three different candidate responses, and they're sort of like a very good response, a mediocre response, and a poor response. The surprising thing was that when the question for chapter 11 came up, all three of the candidate responses, you know, did poorly on the question. And the reason we understood for that is because it is chemistry of the environment. So it's talking about water and it's talking about nitrogen and stuff like that. And
Basic stuff.
with exactly that's the reason why they got it wrong.
They
Right?
thought it would be easy, so let's just.
Yeah, so they just thought, oh, this is like talking about the atmosphere from geography. It's very
Yeah,
basic stuff, and
yeah.
that is how they attempted the questions. That's the kind of answers they wrote with from the perspective of geography and atmosphere and stuff like that, and they got it wrong. All of them got it wrong.
They
And
misunderstood.
so that highlights the point that for this chapter in particular, although it doesn't seem like it has a
It doesn't
lot,
seem much, but it is much.
it doesn't seem like it has a lot to do with chemistry, but you
Yeah,
need to understand it from the perspective of chemistry.
yeah.
Okay,
Okay.
so let me put in the title. Chapter 11, chemistry of the I really don't like the spelling of environment. I always get it wrong. I was very conscious while writing it at this time,
Yeah. Yeah.
right? So chemistry of the environment. And the first thing we're talking about is water, like the British say, water.
Yeah.
So, right, 70 more than 70% of the Earth's surface is covered by some form of water.
And 30% of it being the land, right?
Well, yeah, that would make sense. It's not like you got air in between.
Yeah.
By some form of water, right? So when you talk about some form of water, you've got, you know, uh, rivers, lakes, the sea, right? Something,
Yeah.
rivers, lakes, something. And right, we are mostly water as well, right? So on average, we are like 70 to 80% water approximately, all of us. And right, so humans are like 70% water as well. That percentage might differ how you're looking at it. So if you look at it individually, bones bones are hard, right?
Yeah.
Bones are 72% water.
Bones are made of water?
Well, they're made of calcium and phosphorus and stuff and other tissue, but yeah, there's a lot of water that goes in there. Doesn't seem that way, does it?
Yeah.
Right? Your kidneys are 82% water. Kidneys.
Well, I think that kind of makes sense.
Your blood is about 90% water. All right, so this is like looking at the individual statistics. Overall, right, perhaps 70-80% of your body is water. And then, water has uses, in human life, both at home and industrially. So at home, water is used for cooking, cleaning, and drinking. I'm sure we can all agree with this.
Yeah.
And playing with water guns. Industrially, it is used as a solvent, as a coolant. So we've come across these both as a solvent, as a coolant, for cleaning, and as a chemical reagent.
Chemical reagent meaning?
It's used in chemical reactions.
Oh, okay.
Right? The word that the book has used is chemical reactant.
Yeah.
Right? And so they refer back to some stuff that we've already covered. Right? So we can test for the presence of water in a liquid sample by adding a few drops of it to anhydrous copper to sulfate. And do you remember what happens when you add water to copper to sulfate, anhydrous copper to sulfate?
It reduces.
No,
It increases.
we're not talking about redox.
It just.
Anhydrous. What does anhydrous mean?
Haram wants to answer.
Mm-hmm.
Would you like to answer, Haram?
Makes a liquidity.
It means what?
Makes it. I don't know. I'm sorry.
Anhydrous means without water. An means without. Anhydrous means water, right? So without water. And so when you're adding,
I think that's what Haram said, right? Haram, that's what you said?
so you'd observe a color change, right? Going white from white to blue. And so, right? Obviously, if the liquid is all water, then this is what this is what would happen. If it's something else with water mixed in, then you still observe a color change. So basically, it's just testing for the presence of water. It's not telling you how much water there is. It's just like, okay, fine, there is water. Right. So this is obviously something we just did in the last chapter we covered. And then there's, right, cobalt to chloride as well, which goes from blue to pink. And right, they have cobalt to chloride paper. So the paper is blue and anhydrous. You add water, you'd have a pink spot where the drop is. Right?
Is it like a litmus paper, right?
It's not litmus paper. Litmus paper is used to test whether a liquid, a solution is acidic or alkaline.
I mean, it does change color, right?
Well, yes, that is similar to a
Yeah.
litmus test, just the
Okay.
fact that it changes color. Then we've also covered the electrolysis of water by adding dilute sulfuric acid. So that is something to recall. Right, and the gases that are produced are hydrogen and oxygen in a ratio of 2:1. Right, so 2 parts hydrogen, 1 part oxygen, which is what you would expect from water, because water is 2 parts hydrogen and 1 part oxygen.
Yeah.
Right, the ratio of the atoms is 2:1. So that's what you'd expect with the gas as well. So pretty okay. Then some properties of water. So water is unique. We've gone over this, I believe, in physics, right?
Yeah. Yeah.
So compared to other molecules of you know similar other similar molecules, water has certain properties that other similar molecules do not. So uh, it is, right, a covalent substance So water itself is a covalent molecule, but it's an excellent solvent for ionic molecules. Right, for ionic substances. And the reason for that is due to, right, its dipole or polarity, right, with the delta negative on the oxygen. Let me write it this way, right? The oxygen having the slight negative and the hydrogen having the slight positive charges on them, not complete charges, but the polarities, dipoles. And so those slight charges help them dissolve ionic compounds despite it being a covalent molecule itself.
Okay.
Do you recall we've discussed this already, right?
Yeah.
Yeah. Now, for a molecule of low molecular mass, right? So it's like 16, and like the molecular mass of water is 18 only, I would say. It has an unusually high boiling point. For a molecule of uh, the book says relatively low molecular mass, right? And then it has uh, a greater specific heat capacity than almost any other liquid. Right, and I would ask you to recall physics as well. Right, so we discussed some of these things, in fact, all of these things in physics as well, talking about water.
Yeah.
Okay, and the anomalous, the well, not anomalous behavior of water, right, where its density decreases and it freezes. So normally, when objects go from liquid to solid, their densities increase. Water doesn't, right? It actually decreases. So its density decreases when it freezes. Right? Water has its highest density at 4 degrees centigrade. And so a molecule that is close to perhaps, right, similar to oxygen is hydrogen sulfide, right? So that would be H2S, right? And sulfur is in the same group as oxygen, right? So it also has 6 valence or outermost electrons, just like oxygen, right? It's just coming in lower, so it has more molecular mass. The atomic weight of sulfur is 32, so H2S would be 34, right? Whereas H2O is 18. But this guy, hydrogen sulfide, does not have the properties that water does, right? And so that is a comparison that why water is unique the way it is. Okay. All right. What
Yeah.
else? What else? Let's see. So, right, next they talk about pollution and treatment of pollution. So let's go to a new page for that. Pollution of water. And so pollution is, they define it as pollution is a modification that takes place to the environment right? And the environment could be water or air, and broadly speaking, it could also be noise or soil and earth. And there's also sound pollution, right? So noise pollution. There's also light pollution. So on a side note, right, when you see pictures of the nighttime or videos of the nighttime with the sky filled with stars, I've never had that view. I've never witnessed something like that in life so far, right? And the reason for that is we live in cities that have so much light being emitted from the surface going up, that it actually overpowers the light of the stars. And it's not like the stars aren't there, it's just we aren't able to see them because we are producing so much light from the earth's surface at night, right? And so that is termed as light pollution.
Yeah.
So over here, at least, right, in chemistry, they're only talking about pollution in regards to water or air. They're not even touching on soil, right? And most importantly, caused by human influence. Such as releasing substances in into our water or air. So that is the definition of pollution. So, right, uh,
Yeah.
so obviously all life on earth needs water, and it needs clean water, right? We humans and animals need safe, clean, water for health and all of that. And if there are pollutants, right, they might be biological pollutants or chemical pollutants. And obviously they're contaminating the water, and that makes it less fresh water available, and they can lead to either diseases. If you talk about biological pollutants, can cause diseases such as, right, cholera. They've mentioned diarrhea and typhoid as well. And then you have harmful chemicals in the water as well, which obviously have detrimental effects. Harmful chemicals are toxic, so they will have, depending on the chemical and the amount and whatever, they will have uh, a range of detrimental effects. So, right, water is a very good solvent, as you know, and so naturally, even naturally, uh, right, you won't be able to find uh, pure water in the sense that you only have H2O, right? If you take a sample of water from any river or lake, and obviously the sea, right, or any other natural water body, you will have other stuff mixed into it, right? So natural water sources do not have pure water, right? That is not to say that the water is, polluted. So if you've got mineral ions or other, substances dissolved in water, if they are in the right natural concentration, it might be okay. The only thing is that we aren't used to it the way life has become, right? What we consume, right? What we use as mineral water, right? Mineral or processed water, right? Is like, distilled, and RO plants and all of that. So in labs, you use distilled water, you've got mineral or processed water for human consumption. And so we aren't used to consuming water from natural sources anyway. If you go to a lake and you see the water's clean, it definitely has microbes in it, it has bacteria and other organisms in it, right? And it has other salts or substances mixed in, and it might be okay, but since our body isn't used to it, you're probably going to get sick if you drink it. Okay, so right, what would you have in natural water, for example, right, or water in general, whether it be uh, you know pollutants from due to human activity, or something that you would expect to find naturally. So for one thing, water has a number of dissolved gases. Without what, like, right, you go anywhere, and so water has a number of dissolved gases, such as you have oxygen and carbon dioxide. Right, so the oxygen is actually, oxygen dissolving in water is important for life, right, especially aquatic life. So the dissolved oxygen is essential for aquatic life. So the fish also need oxygen, right? But they get it through the water. And the carbon dioxide, gives water a low level of natural acidity. But the problem is, right, with all the pollution that we are churning out, we've been churning out for multiple years, the amount of carbon dioxide in the atmosphere is increasing, and that is increasing the amount of carbon dioxide dissolved in water, and that is changing the acidity and thereby the pH of water, which is affecting all life, right? So more CO2 means more acidity in water, right? Changing pH, which affects all life. Then you have nitrates and phosphates in water, and these aren't as naturally occurring. So these guys are coming from chemical fertilizers, from agricultural use. So nitrates, and so nitrates look like this. You got compounds with the nitrate ion. So for example, right, it's coming from fertilizers. You would have example from ammonium nitrate, so NH4NO3, and then you've got phosphates, right, which have the phosphate ion, which is PO4 with a -3 charge, right? And this is, for example, coming from ammonium phosphate. So you've got NH4, the whole thing thrice, and then PO4, right? So ammonium phosphate. And so these two are examples of chemical fertilizers. They are used in agriculture, which basically means used to grow crops. And why would they be used? Well, to provide nutrients to the soil, because when you are growing crops in large quantities on land, then they're going to take up the nutrients from the soil, and so the soil will be depleted. So how do you replenish that? How do you give this provide those nutrients again so that you can continue growing crops, right? And
Yeah.
so you use these fertilizers, right? You're using agriculture to replenish the nutrients in the soil or the land. But what happens is that when water flows, either they're leached into the groundwater. So, right, these nitrates and phosphates are either leached into groundwater or washed uh, they're washed off, right? So if it rains or if there's like some water flowing over that part of land for some reason, then they are taken away. And if there's like a water source nearby, there's a lake or a river, so they all go in. And so what that does is it increases the concentration of these guys in the water body, and that has detrimental effects. So it contributes to pollution, and that it has, right, noticeable detrimental effects. You can also get these guys from detergents. So detergents have phosphates as well, and both domestic, so used at home, and industrial detergents. Domestic and industrial have phosphates. And so what are the detrimental effects that we're talking about, right? What they cause is they encourage growth of algae or algae, right? And right, it's called an algal bloom. So encourage growth of algae in the water, which is called algal bloom. And so there's like this rapid growth of algae, and because of that, right, they grow rapidly and they use up resources and then they die, right, which they eventually die and then decay. And the process of decay, right, so there's a biological aspect to it as well. I don't believe they've mentioned how that happens. And so in the process of decay, right, they are, right, oxygen is removed from the water. Oxygen is lost from or removed from the water body, right? And so that is deoxygenation. And as you can imagine, if there's oxygen being lost from the water, it's not going to be supportive of any life, right? Either aquatic, and even if you drink it, it's going to cause, serious health uh, problems for you as well.
Yeah. Okay.
Okay, then you've got metal compounds in water. Right, and these are coming in from industrial wastewater. So when we talked about the extraction of aluminum from its ore in the chapter of electrolysis, electrochemistry, they mentioned that when aluminum is processed and whatever that sludge and everything that's left behind, it's right released into a water body, and that it causes the water body to turn red, right? And a picture is given in the book in the relevant chapter. And so, right, one of the concerns about the extraction of aluminum is, right, the harmful effects, the pollution that it causes to nearby water sources. So that's just an example, right? There are others as well. So metal compounds from industrial wastewater, such as cadmium and mercury. And suffice it to say that they are toxic. Right? It's not something that you want to be consuming. In fact, I'm not taking the name of which country it happened in, because I'm a bit sketchy on that. But there was mercury poisoning in the water, which caused most of the fish to die, right? Or
Yeah.
at least be poisoned. And so what happened with that is there was mercury in the fish, and when the fish were caught and sold to obviously people, and they cooked and ate it, and so mercury, they got mercury poisoning, and it was like really a really bad situation, right? And so
Yeah.
then there were steps taken to stop mercury being disposed of in these water bodies and causing
Yeah.
that harm. Okay, now they mentioned, rightfully so, right, that not all metal compounds are toxic. So, right, as you mentioned, that natural water has a lot of stuff mixed in, and if it's in a natural condition, then for the ecosystem and for the organisms that depend on it's okay. Again, we're not used to it, so we'll probably get sick, but for nature it's okay. So right, not all metal compounds are toxic, and some are even beneficial.
Yeah.
An example is calcium. Right, so even though the form that we see calcium is, like see these calcium tablets and they're all white and stuff, or we see limestone calcium carbonates like this white powder, and like it's not a metal. Calcium is a metal, right? So
Yeah.
right, whatever form of calcium we see, it's like some salt and it looks that way, but it is like right, they're just like sodium chloride, right? Salt, the table salt that we use doesn't look very metallic, does it?
Yeah.
But sodium is a metal, so those compounds are made of metals. And so right, calcium is necessary for healthy growth of bones and teeth. So it's not all bad, obviously, having the toxic ones going in there, which you would not normally find or not find everywhere. Maybe there's some natural water bodies that have these occurring, and so you call that water body toxic for humans at least. But otherwise, right, you don't normally have cadmium and mercury and lead and aluminum and all these guys in water. Okay, we still have a bit of time. So there's obviously the problem of human waste. From sewage. Right, and obviously, right, it contains, among other things, harmful microbes. Microbes meaning microorganisms that cause disease. And then you've got insoluble impurities. Insoluble impurities, such as oils and plastic. And this is something that obviously I and people over here have, right, they contribute to as well, and it's like you know I haven't seen a clean water body in forever. Right, in Dubai or UAE, you probably don't come across it as often. Maybe you have seen the occasional plastic bag or plastic bottle floating in the water, but not so much.
Yeah.
Right, but in some regions it's uh, pretty bad, or
Yeah.
I would say many regions it's pretty bad. Right, and so you've got oils and plastic waste producing, whether it's rivers or lakes or streams or oceans, whatever, it's everywhere. Right, and obviously it is detrimental to aquatic life as well as humans, so it is detrimental to aquatic and human life. Right, these kind of pollutions, among others, in right, fish get tangled in them. Right, plastic fishing nets, they swallow plastic bags or fishing lines that are made of nylon, right? So that's plastic, a form of plastic. and so they choke and suffocate on them and die, or they get trapped and die in those fishing nets, and it's really causing havoc, right? It's obviously pollution, so it also causes not only problem to human life but the human way of life, because right, if you've got all this junk in the water, and then whatever the water system you have, those drains and pipes and passageways get clogged and contaminated, and so like problems everywhere. So
Okay.
human life. Okay, now next up is the right process of filtering water. So I'm going to, you know
I mean, you have 30 minutes.
I kind of do, yes.
Would you like to continue?
I'll take you to the book for this one,
Okay.
right? It's a stepwise process. It is illustrated as well in the book. So I'll use that. Can you see it?
Yeah.
Right, so it starts from here. So a lot of the drinking water is obtained from lakes and rivers where pollution levels are low. Right? So that's the first thing. You obtain it from a source where you got low pollution, and then it is filtered and treated to remove, other pollutants and undesirable materials. And then, it is also chlorinated. So chlorine is added to it to kill microorganism stuff and make it safe. So the first step is that impure water is passed through screens to filter out floating debris. So the larger, junk, right? That's obviously not that bad, as you can see, right? But right, if there's anything, any large thing floating in the water, that's the first thing that's filtered out, right? So this screen, so this is the illustration for the entire process, and so you've got this sort of, you could say, large net to catch anything that's big enough. Then aluminium sulfate is added that coagulates, right? Coagulates means it clumps together, right? Coagulates small particles of clay so that they form larger clumps which settle more rapidly, right? So here you've got aluminium sulfate, and so right, any small particles, they clump together, that's called coagulation, and then because they clump together they become heavier, and so they settle to the bottom, and so they're easier to remove. Then you've got filtration through coarse meaning, right, they're bigger grains of sand as compared to fine sand, right? So desert sand is fine sand. uh, Maybe the sand that you find, I don't know, in,
Yeah.
I mean, I can't think of where you'd find coarse sand, right? Naturally, it's not coming to mind, but any, right? So it's filtered through coarse sand traps, so that larger soluble particles are filtered, and the sand also contains specially grown microbes which remove some of the bacteria, right? So they're removing bacteria. So that's step 3 over here. Then step 4 is a sedimentation tank. So remember sedimentation, where, right, solid particles come out of, solution. So, well, that's actually precipitation, but sedimentation tank, right? So you have chemicals known as flocculants, such as aluminum sulfate, which was right over here earlier. So they're doing that same process again, and so they are causing the smaller particles to stick together, make clumps, and then so anything that's left, they want to further remove it. And so sedimentation is when those particles, right, settle to the bottom. That's called sedimentation. Okay.
Okay. Yeah.
So not to be confused with precipitation, what I mentioned earlier was precipitation. Sedimentation is when you've got particles. So for example, you take a bit of water, and you maybe experience this if you've gone to the beach, right? So you take some water from the sea, and it's not clear, right? It has sand mixed in it. But so initially you see that, oh, sand is floating in it, but you leave it for like 10-15 minutes and you see that the sand has settled to the bottom and you've got clear water on top. So the sand settling to the bottom is called sedimentation.
Okay.
Then step 5, the particles are removed by further filtration through fine sand, right? So that's over here. And this is followed by carbon slurry filters, which are there to remove unwanted tastes and odors. And a lime slurry is used to adjust the acidity, right? So that's all happening over here in step 5. And then finally step 6, a little chlorine gas is added which sterilizes the water. Sterilizing the water means killing microbes, killing microorganisms, and kills any remaining bacteria. Excess chlorine can be removed by the addition of sulfur dioxide gas. Right, this is stuff that you just need to know. They're not giving you any chemical equations for the process or anything, right? The addition of chlorine gas makes the water more acidic, and so appropriate amounts of sodium hydroxide solution are added to neutralize this. So you've got a base, you're adding it to neutralize the acidity to bring it near pH 7. Fluoride is sometimes added to the water if there is insufficient occurring naturally, as it helps to prevent tooth decay. So you're probably familiar, right? You've got fluoride toothpastes and healthy, teeth and stuff like that. So right, that step 6, chlorine is added, and then sodium hydroxide is added to neutralize the acidity caused by chlorine. And then, right, you've got the storage tank, and from there, right, if required, sulfur dioxide is added to, if there's too much chlorine, so to neutralize, remove the chlorine, and then you finally have it going to juice. Any questions about the filtration treatment process for water?
No.
No.
Haram, you okay?
No. Yeah.
Okay, right. So yeah, that's all, and we'll continue with this later. Do read through the book. All right, this was like a straightforward process. Again, there was no technical chemical detail, no equations to explain, and so right, I just went over the steps as they are given in the book. All right.
Well,
All right. So I'll see you guys next time then.
okay. Inshallah.
Allah
Allah
Hafiz.
Hafiz.
Allah Hafiz.